right, so initially this question is asking us to graph this absolute value function. So the first thing I want to do is I want to get my vertex, which tends to be the starting point of all parabolas and absolute value graphs. The x-coordinate will always be what makes the absolute value equal to 0. In this case, it's -2. And the y-coordinate will always be what's on the outside. In this case, it's 3. And essentially, we're following this general formula. Y equals A times x minus h plus k, where hk is the vertex. Okay. Now, unfortunately, my graph is going to be tough to see. We'll do the best we can with it. All right? But my vertex is -2, 3, which means I'm going -2 over 1, 2, and then I'm going up 3. So that's where my vertex is. -2, 3. You can plot that point on your graph. Now, the A value is 1, which we can use as a slope. Honestly, I kind of like making the chart. That's me. Your other teachers may have you use slope. I really would prefer to do -2, 3. And since there's no fraction outside the absolute value, I'm going to count down by 2 and I'm going to count up by 2. When I plug -1 in for x, -1 plus 2 is 1. The absolute value of 1 is 1. 1 plus 3 is 4. So when my x is -1, my y is 4, which means when my x is -3, my y would also be 4. I plug 0 in. 0 plus 2 is 2. The absolute value of 2 is 2. 2 plus 3 is 5, which means 2 on the other direction, -4, would also give me a 5. So I'm going to plot those points, which are -1, 4, 0, 5. -3, 4, -4, 5. And that's really enough for me to do a sketch. And remember, we want to make it look like a V. An absolute value is a V. The y equals x squared, the parabola is a curve. This really should look like a V. Now, what is the transformation from the parent graph? Remember, the parent graph, if I put in a different color, is this. Okay, that's your parent graph. And where did I go? Every point is left 2, up 3. So if I went here and go left 2, up 3, every point shifts the same. So the transformation would be left 2, up 3. Essentially, in an absolute value graph, the transformation, okay, when the A value is 1, is kind of whatever the vertex is. The vertex tells us our shift when the A equals 1. When the A doesn't equal 1, we have to make some adjustments to it. When the A equals, all right, when we go to graph a quadratic equation like this, okay, we're given this trinomial, we have to use -b over 2a. So in this case, it's going to be -4 over 2 times 2. -4 over 4. So my x-coordinate of my vertex is going to be -1. I plug that -1 in. -1 squared is a +1. So we get 2 minus 4 minus 7, which is a -9. So my vertex here is going to be -1, -9. And I should know the axis of symmetry is always x equals whatever the x-coordinate of the vertex is. Now I'm going to draw my graph to demonstrate the increasing and decreasing spots. This graph's vertex is at -1, -9, which is right here. Okay? Once again, I'm a fan of the chart. If I do x, y, and I put my vertex in, I get -1, -9. I'm going to go down 2. I'm going to go up 2. When I plug 0 in for x, I get -7. Which means if I plug -2 in for x, I get -7 because it's symmetric. If I plug 1 in for x, 1 squared is 1, times 2 is 2. 4 times 1 is 4. 2 and 4 is 6. 6 minus 7 is a -1. And that's really enough points for me to graph. So my points here, I'm going to use 0, -7. Have to move this to -1, -9. 0, -7. 2, -7. We're going to use 1, -1. We're going to use -3, -1. And in my mind, that is enough to draw my parabola. So when I draw that, it is a sketch. Make no mistake about it. Hopefully you draw a better line than I did there. Yikes. Sorry about that. Me. Thought that would go a little better, but it did not. Let's try those dots again here. So we're going to do purple. There we go. There we go. There we go. Put those dots in. Hopefully I can draw my line through the dots. All right. It just does need to be a rough sketch, but please make sure your graph is curved. Where is it increasing? It's going up from -1 to infinity on the x-axis. Remember, increasing is all about the x-axis. Where is it decreasing? It's decreasing from -infinity to -1. And that's how we deal with the decreasing. So when we do this problem, we're doing it based off of the vertex form. And that vertex form is this. This is probably one of the simpler problems in terms of it's straightforward. I'm going to put my point 17 in for x and y. So 7 in for y. A times my 1 is in for x. My vertex is a specific point represented by h and k. 1 minus a -1 squared plus 3. Okay? So when I go through this, it's 7 equals a times 1 minus a -1 is 2 squared plus 3. You've got to do the square. So 2 squared, it's 4a plus 3. We subtract 3 on both sides. We get 4 equals 4a. My a actually equals 1. It actually works out very nicely. So my answer, if I had any other number other than a, I have to write the number a in. In this case, the answer is literally y equals x. You always put the vertex back in. We don't write minus a -1. It's plus 1 squared plus 3. And if you plug your point in, it should work out. 1 plus 1 is 2. 2 squared is 4. 4 plus 3 is 7. Factoring. There's no equal 0. We're just factoring. My advice, 5 is the easier number to work with. So I am going to put 5x and x in the first 2 spots in my first 2 parentheses. My factors of 8, 4 and 2, 1 and 8. I put the 4 here and the 2 here. That gets me to 8. My middle term of 20x and 2x, can I make that equal -18? I certainly can by making my 20 negative. So it's a -4 and a +2. So that is literally how we're going to factor. And there's your answer. The next one, completing the square, we got to remember the process. First step, you've got to get a 1 in front of the x squared. Cannot do this without a 1 in front of the x squared. So this becomes x squared minus 4x plus 6 equals 0. My next step, move the constant over. X squared minus 4x equals negative 6. Now this next step is a slight coincidence. We take half the middle term and square it. And that's 4. And therefore, if I add 4 to one side, I have to add 4 to the other. I'm getting that by taking this b term, which is negative 4. I'm taking half of negative 4, which is negative 2, and I'm squaring that. Oops. Sorry about that. And I'm squaring that, and that gives me a 4. That's where this 4 comes from. It's not the same number here. If this middle term here was 6, it'd be plus 9. If the middle term here was 8, it'd be plus 16. Half the middle term, and we square it. And then we factor the left side. And it will always factor to a binomial squared. In fact, you can always put half the middle term with its sign. Over here, I clean up negative 6 plus 4, which is negative 2. Then we take the square root of both sides. Which in this case is square root of negative 2. And that is x minus 2, x minus 2 squared. That is x minus 2 equals plus or minus I root 2. You have to simplify that radical. And then we finish by adding 2 to both sides. So my answer is 2 plus or minus I root 2. That's completing the square. If you're asked to use quadratic formula, we're talking about negative b plus or minus b squared minus 4ac over 2a. Now in this problem here, I could literally make my problem easier by dividing everything by 2, taking a GCF out. I'm just going to use the numbers as they are. A is 2, B is 4, C is negative 10, and we keep the signs with the numbers. This becomes negative 4 plus or minus 4 squared minus 4 times 2 times a negative 10, all over 2 times 2. So negative 4 plus or minus 16, 4 squared, 4 times 2 is 8, times negative 10 is negative 80. When you subtract the negative 80, it's really plus over 4. So the answer is negative 4 plus or minus root 96 over 4. Now, you do have to simplify a little more. I'm going to take this 96 and I'm going to break it down. 48, 24, 12, 6, 2 and 3. Pair of 2's, pair of 2's. So when I break this down, the root 96 simplifies to 4 root 6. And now I can divide both terms by 4. Negative 1 plus or minus root 6 is my answer by quadratic formula. When they want the discriminant is literally the portion directly under the radical. That's your discriminant. My b is 4 minus 4 times 2 times a negative 10. 16 minus a negative 80 is 96. Since 96 is greater than 0, we have 2 real solutions. If the positive number was a perfect square, it would be 2 rational solutions. If the discriminant were equal to 0, it would be 1 double root. If the discriminant was less than 0, whether it's a perfect square or not, those are 2 complex solutions in terms of your answers.